Okay, I'd like to go through some conceptual ideas to do with square roots. So you'll have learnt from GCSE that the square root of a is the same as a to the power of a half. But why is this true? Well, let's look at root 2. So what is root 2? Well, root 2 is the number that if you square, you get the number 2. That's what a square root is. So if we think that the square root could be a 2 to the power something, the blue equation must be true. And also, by the rules of indices, we multiply x and 2, and that must be equal to 1. So x must be a half. That power must be a half. So these two things must be equal. The same is true if we think of a cube root. The cube root of 2, we would need to cube to make the number 2. So we must have 1 over 3 left as the index in that case. I also want to look at negative indices and see why, in particular, a to the power of minus m is the same as 1 over a to the power of positive m. Well, let's look at 2, the base 2 again. If we look at powers of 2 that are descending, so you see them appearing on the screen, going down, and we reach 2 to the minus 1. Well, if we think about the right-hand side, each time we are dividing 2 as we go down, dividing by 2 as we go down. So 2 to the minus 1 is 1 over 2. And if we divide 1 over 2 by 2, it's 1 over 4, yes, but actually thinking about it, it's 1 over 2 squared. And if we went down again, it would be 1 over 2 cubed and 1 over 2 to the power 4 and so on and so on. And it proves our equation at the top. Well, it demonstrates it, it's not quite a proof. Okay, some examples for us to go through now. I'd like you to copy these down if you can. The solutions will follow. So the first thing we do is we change all the roots into powers, and then we apply the laws of indices, which you see down the left-hand side of your screen. We're applying the division one down here right now. We subtract the powers. Now in this case, the powers are fractional, so that makes it a bit more difficult. And if you do that subtraction, you get x to the sixth root of x. Similarly with the second one, we are changing our roots into powers and then obeying the laws of indices that we already are quite familiar with. And for the last one, again, it's the same problem. We are multiplying 3 and 4 to get the 12, turning our roots into indices and adding our powers, and that's where the number 4 comes from, 8 over 2. Okay, we're going to be evaluating numbers with these nasty powers. Again, this is GCSE fodder, so you should be familiar with it. The trick, as I understand it, is you get rid of the negative first, if there is one. Then you get rid of the denominator, the 3. You're going to take the 1/3 inside a bracket and have the power of 2 outside. Now 1 to the power of anything is 1, so the numerator has taken care of itself. 64 to the power of 1/3 is the third root of 64, which is 4, and 4 squared gives us 16, and that is the final answer. When our power is a fraction itself, we still have to apply it to the top and bottom number in the same way. Now this time it's like the first example, except we've got the numerator and denominator having the 1/2 drawn inside. So the square root of 9 is 3, and 3 cubed is 27. The square root of 4 is 2, and 2 cubed is 8. And that explains the final step. With our last example, there's a negative. That goes first. We flip the fraction that is the base of this power. We then take the 1/3 inside and apply it to both the top and bottom number. I'm just being lazy here and writing 1 squared, so I'm applying it to the top and bottom. Our fraction inside the bracket simplifies to 3 over 5, and if we square the top and the bottom, 3 and 5, we get 9 over 25, which is our final answer. Okay, the last set of examples concern these two things put together. We're going to apply our rule of indices, which is if we have a power and two factors inside, we apply it to both factors. So 16 to the minus a half and x to the 4 to the minus a half. And we proceed evaluating each of those as we did in the previous examples. When we have a fraction with two terms on the top, we have to take out any factors first. Only then can we take factors of x out of our fraction. We take two x's out of our numerator and two x's out of our denominator. You could think of it as a subtraction if you want and have x to the minus 1 at the top. There are numerous ways you can write this. This is just one example and it is fine. So if you have an expanded version or anything with negative indices, that's okay as well. Okay, time for you to stop the video, go and have a look at the exercise that I believe is exercise 1D and the highlighted questions therein. There should be some added extension material for those who finish quickest.